haven't seen him yet, but he wanted to be.
Who's online?
Yeah, he wanted to be.
I'm here, Farasat.
Oh, excellent. You can hear me. Really,
Are you self-regulating, Farasat? Just so I know when to...
I asked Joe to keep me in check.
Okay,
Joe
so
is
I
there.
know when to
Joe is the
rush
one
out with the
who's.
teapot and
yeah.
rush back in again.
So should I get started?
Yeah.
Okay, thank you very much for being here. My name is Farasat Bokhari. So some of you know me, some are from the law students. Law school may or may not know me. I'm here with my co-author right over here, Stefan, and a student, Jan. This paper that I'm going to present is part of his PhD. It's one of his chapters. By right, he should be the one presenting over here, but he couldn't be here today. So on the short notice, asked by Sean to provide the paper, I'm over here today. So all the great work has actually been done by Jan over here. And if you see any errors and so on, that's either my fault or Stefan's fault, where we asked him to do something strange. So he's online and he's here to help with the difficult questions if those come up. Okay. So this paper is about using experiments. Stefan is a behavioral and experimental economist. I do a little bit of IO, and we were lucky enough to have a student who is interested in both things. And so this is the outcome of that thing that happens when an IO economist meets a behavioral economist, and there's a love child that comes out of it.
So you want to advertise the sequel on the 1st of December? Or shall I say a word on that? Because Jan is presenting another joint paper on the 1st of December.
Yeah, so Jan will be presenting a follow-up paper in December 1st, which is on use of alcohol in certain laws that came in. So here, for that, he'll be here in person. Anyway, so this one is using lab experiments to try and understand something about merger reviews. But that's not the only application we can think of over here. There are other applications as well. So generally, the issue is that there are often between 1/3, half to 2/3 of EC's merger cases that use either upward pricing pressures or diversion ratios to study what are called the unilateral effects. The idea is that if firms are going to merge, what type of impact will it have on, for instance, prices and things like that. But one way of getting to these is to do proper demand estimation. If you want to understand these things properly and see what the right effect is going to be on the prices, and you use merger simulation. But to do all of that, you have to initially do demand estimation. And some of the stuff that goes on in demand estimation turns your hair white, which is what's happened to me over the years. Because it's quite difficult stuff to do, it requires a lot of data availability, it requires a lot of training. And often enough, the time is not there in merger cases, for instance, in the ex-ante period, because those are done in a very strict timeline. So for instance, in UK, CMA has 40 working days to complete phase 1. And US and other places have similar timelines in which to try and figure out whether the merger should go through or not, or whether it should proceed to phase 2 inquiry or not. Even in phase 2, you typically do not have that much time. I was lucky enough to be sitting in a couple of phase 2 cases for CMA this previous term, and the speed with which these cases have to go through is quite incredible, that you have to absorb all of that stuff. But the main point still remains that what we would like to be able to do is that if a merger comes through or an application comes through, you want to look at that, and you want to be as careful as possible in trying to do some sort of an assessment what's likely to happen should the merger go through. So that's called the unilateral effect. And there what you want is maybe some sort of demand estimation followed up with some sort of a merger simulation. But the reality is quite different. So demand estimation is the use of structural empirical models. There's lots of different ways that one can try and estimate it. The main working horse in at least the academic literature nowadays is the random coefficient mixed logic models, which are not easy to estimate. but they do provide very powerful tools, and they provide very reasonable substitution patterns, which are quite important to be able to understand. So demand estimation is difficult. It makes assumptions about what the world will look like under certain conditions. Sometimes you don't even have the data to even be able to do all of this type of stuff in the ex-ante world. And the right models can be very difficult to estimate because of issues related to endogeneity of prices, assumptions about the type of form of computation, and so forth. So combine this with the time constraints, these factors may limit the ability, for instance, of competition authorities to employ these methods upfront. So they can be used a lot more in the ex-post analysis if you're doing reviews of mergers, but ex-ante it's hard to do. So here's a quote from Tommaso Velletti, which I've actually heard him say in a couple of conferences as well. This particular one is taken from a specific publication. But he was the chief economist for 3 years, and his point was that, look, BLP, which is the Barry Leventhal-Pecos method, known after them, which came out in mid-90s, and is the most advanced method of using demand estimation. There's been a lot more work and progress made on that methodology since then. But in his 3.5 years of being, so 3 years of being over there, he's never seen a single case where he says that they actually use these methods, even though we use it quite a lot in academic literature. So you can't go without in the academic literature doing these type of things when you're using it. So the general idea is refers to demand estimation. From that, you end up backing out some sort of marginal costs by assumption of the form of competition that takes place. And once you've got the parameters of the demand estimation, you've got some estimates of the costs that the firms are going through and type of competition that takes place. You put those things together, and then you say, okay, here's our best case scenario in terms of looking forward and saying what all might happen in these cases. So what are we going to do over here? So one question that we were thinking of over here was that what if we can increase the speed of this process and make it a little bit easier to do this type of demand estimation in the ex-ante world? Now that's not the only application. You can also use other places where you can do other type of counterfactual exercises. So for instance, policy exercises you can do. But the idea is that we can perhaps use experiments to figure out the key parameters that go in these models. And if we can use the experiments to figure out the key parameters, and we've got values of those and they have some external validity to them, then we can use these parameters and proceed in similar way as one might have proceeded either in some sort of a policy counterfactual or some sort of a merger counterfactual. So we're going to run an online experiment using hypothetical choices to obtain demand parameters. Once we've got those, so here we've got the parameters that go inside a utility function essentially, and that's the key thing that we're going to try and get from the lab experiment. Then the problem comes in our application, which is that to do the next step of the merger simulation, you also need to know something about the costs or the marginal costs of the products. So you can either find some accounting data and get some guesstimates out of those, or use some other trick. Now, in the real cases, when there is actual real data available and you are doing some sort of demand estimation with real data, the way this answer is often addressed by researchers is that they've got demand parameters and they say, okay, here's our demand parameters, here's our elasticities, here's all this nice stuff that is coming out of it. Here is the actual observed prices that we have. Now, given that these prices are there, given that these shares are there, and we've estimated these elasticity matrices, what would rationalize, what type of cost structure would rationalize the prices that we're observing and the shares that we're observing? And they figured that out by saying, well, one way to proceed is to figure out what is the form of competition between firms. So if you make the assumption that the firms are competing in prices, then you can put these two things together and figure out or back out what the marginal costs are. Now, our problem in the lab is yes, we can get the utility function parameters for individuals, but where are we going to get the costs? That's not going to be available in a lab. So here what we do is we take the utility function parameters and we say, let's go get some actual real data from just one market perhaps. Now you might say, well, if you have real data, why did you bother doing all of this? And I'll come to that in a bit. But the thing is that we can take very limited real world data, mix that with the utility function, then proceed in exactly the same way as one might have proceeded with full-blown data from all sorts of markets. And then you can back out certain amount of certain values of marginal costs. So that's what we're going to do using some sort of a Nash-Bertrand equilibrium. Then using estimated demand functions and the marginal costs that we've just backed out, we can then mix these things together to figure out what the substitution patterns are going to be, what the elasticities are going to be. And these can then be used to further compute diversion ratios. They can go into other type of exercises like upward pricing pressures, if that's the type of exercise the competition authority may want to do, or undertake some sort of a formal merger simulation exercise, because all of those things can be done with the same type of estimates. So that's the underlying idea over here in this. Any questions about any of this so far? You can ask, can this be, as anybody else has done this type of thing? So obviously we're going to do these lab experiments using some form of stated preferences. There has been a recent paper that has actually applied very similar trick in estimating the preferences for guns and figuring out substitution patterns between handguns and assault rifles in the US in order to figure out how much is the substitution between these different types of guns. Now that's done in a very different context. They don't have to work out marginal costs and simulations and so on.
So you're using, it's like a survey in a sense. You're using your experiment to try to estimate the actual preferences of people out there in the world.
Exactly, yeah. But we'll have to make certain deviations. We don't have incentivized experiments over here. So we'll have to do elicit their preferences by just asking them and giving them certain choices.
And how do you get them to match up to the real market? I mean, the people themselves. You know, you're sampling. How do you get your sample to match the world? Oh,
So,
you tell us this one.
So I'll come to that in a minute. Yeah. Thank you. So our general idea is that, okay, we want to know the demand parameters that we're going to get from the lab experiment. Okay. So we're going to give people some choices. We're going to make them pick between products, different products with different characteristics. Those characteristics can differ either along the dimension of price or other types of fixed characteristics between those products. And once we have that, we also know from the real world the ownership of different products that map to different manufacturers. And then on top of that, we're going to superimpose the actual prices and shares from the real world, just from one market rather than from all geographic markets and so on, which can be very, very demanding work, to then come up with our own measures of elasticity. Of course, in the end, we'll try and provide some external validity to all of this to see if it matches what one might get from the real world data as well. So we're going to collect data in an experimental or survey situation. So we give them hypothetical choice situations and hypothetical responses, common in other branches of economics, obviously. People can do these, have done these type of methods in other places. So we have the stated preference method over here. The main point over here is that these can be done very quickly, these type of gathering of the data. You can set it up on Prolific or MTurk or things like that, enroll people. You can target the right demographic group that you're interested in. In our case, we did it or demonstrated with the one particular type of demographic group, but in general, you can choose all sorts of demographic groups. You can get the enrollment very high, very quickly, and then you can put in things over there to make sure that people are paying attention to it. They're not just clicking buttons to get through the survey to collect their money, whatever they're going to do, and target certain groups that need it. But they also come with certain difficulties that we note over here, that it's not easy peasy. There are certain issues that come up. And we're going to try and provide some guidance into what happened with us, where we found difficulty, and what we learned from it and which way it can go. So the hardest part for us in here was incentivization. One of the hardest parts, yeah.
Sorry, we've got a, Jens would like to participate.
Yeah, please go ahead. Just go ahead, Jens.
Yeah, hi Farasat. Thank you. One question, kind of why do you use hypothetical choice situations here if in the end you want to match these data from the lab with what you see in the real world? I mean, you know what real products do exist and which are the main competitors. Why don't you kind of take this information and present it to people in the lab?
So to some extent we do that. What we do is that our choices that we provide, we take them, we are motivated from the real world product characteristics. And we look at the range of values that can appear over there, both in terms of prices and as well as other product characteristics. But what we have the ability to do over here is to create sources of variation. So we can exogenously change the price that a person will see. We can exogenously change certain other product characteristics, and we can repeat these choices over an individual so that we can see that for the same fixed price and different product characteristics, what the person saw. So that could be one source of variation that you could have. Then we could see basically that if other things are kept constant, but the price has changed for that similar product or same product, how they would react, and then we could match it over variation over different people that are in our experiment. So the product characteristics that we're going to show them are not going to be completely something that we make up. They're going to be motivated with real world product characteristics. It's just that we in a lab can provide a good source of a good exogenous source of variation over here to get identification of these parameters.
Okay.
I can see how you could do this as a kind of proof of concept, but surely if you're actually going to do this in real, you couldn't do it through. Seems to me, I mean, when people do contingent evaluation of say health willingness to pay for healthcare, I mean, in the end, the data that the government actually uses has to be taken from a random sample of the population, and I don't see how you could do this. How you could do this from prolific or anything else, because you're not a random sample to begin with. So if you in other words, it's one thing to use this to test the methodology, and that's fine, but I don't see how you could ever extract information from a prolific that was actual parameters for the world, because you need a random sample.
Well, I mean, so we're going to apply it to the context of beer drinkers. And we're going to give them choices about that, and we're going to try and extract some information over here. The way we're going to do it is we're going to select people who are beer drinkers, and so know something about those things. Now, can we verify that they haven't lied or something like that when it's entering? We can't. They could have lied about it. But I mean,
but you're forced though to have got your prolific, your basic sample frame is prolific, isn't it? It's not beer drinkers, it's prolific beer drinkers. So anything that's peculiar to prolific users is going to come through in a way that. I mean, I know.
Yeah, I mean, that's certainly true, that if the drinkers on prolific are different from the real world drinkers, let's say that there's some sort of truck drivers that are drinking beer and they just don't sit on prolific to earn 2 or 3 4 pounds extra, we're not going to capture that.
There are going to be prolific people are going to be a very, very special sample, and a very special type of person.
Yeah.
Anyway, that's.
I mean, so but we can get into the issue of, did we get the right sample over here or not? So the first idea is proof of concept.
Yeah.
But certainly your second point, that if you're targeting just the wrong population in here, then obviously it's not going to work. So down the road, as you look at these methods, you can say, can in a lab experiment or can in some sort of online experiment, can we get the right people in there to go and answer these questions? So what you want is typical customers. So if there's a merger going on, you want to have typical beer drinkers there. Right now, we had to do this experiment in the times of COVID, so we ended up doing it on prolific. But yes, getting the right population in there would be very important. Although we do think that we have reasonable control over the population, except that there was an oversampling on females in our cohort. Okay. So the experimental design is that we in here show it for beers. You pick a product where you're interested, where some sort of activity is going on or is under review. You then look at the attributes that are important for those products that are merging or potentially that they're going to merge. Define number of values of attribute levels, define number of choice sets and options in each choice set. Now, these basically are the way where we're going to generate the exogenous sources of variation, and you're going to pick them from the ranges that you observe in you can just even go on the internet or visit a shop and you can see what characteristics of beer are important, can or bottle, local or foreign, price certainly, value of ABV. These are the type of things that could be quite important. Then we create combinations of these so that there is reasonable variation in all of those, because if you don't have enough variation in some of these, then obviously you're not going to do it. In our case, we're going to have two lab treatments. Treatment one or choice set one is an intra-brand choices. And this is because we think that getting some of these advertising type of issues that are there in the real world are very hard to capture in a lab. So one set of experiment is going to be intra-brand to see what happens over there, where we basically give them choices where they're not focused on the brand name associated with that product. They're really focused on the attributes. So we're going to give them a choice that, okay, here's a type of beer that is coming out. Which of these attributes do you like more? Choose one of those, right? So they don't have to figure out, do they like Michelob more or do they like Coors more or something else? And the second is the inter-brand choices, where we give them same choice set again, but we make the brand name very salient. So right in front of the choices, they'll be able to see a label that which type of beer they're choosing, because we wanted to see, given that we cannot do incentivized experiment over here, could it be that people are engaging in cheap talk? They just respond to whatever they think is the coolest beer to drink and just check that off because there's nothing coming out of their pocket. So we wanted to see how much of a difference there's going to be. Now, this where there is a brand effect is also there in the paper that I just mentioned about gun choices. The gun choices paper, in their experiment, we noticed, have also put in the pictures of the actual guns along with the labels of the manufacturer. So Glock&Smith or this or that, or Winston, whatever the names are. And there is some nice similarity between the type of result that we observe in brand effect versus what they're observing in the gun side of it. And I'll come back to that point towards the end when I'm showing the result. Okay. So what do we have? We focused on just 4 attributes. In retrospect, we should have really added in one more, which was more like foreign versus domestic beer. But as proof of concept, it doesn't matter. We focused on 4 different characteristics. One is the price. So we have 3 values of prices that people can see. They're randomly given one of these prices. Then they have the value of ABV, which is the amount of percentage of ethanol inside a beer. Whether or not it's a can or a bottle, because some of the literature we saw often use that as an important characteristic in beer. And then the size of the bottle. Is it a small bottle or a big bottle or small can, big can? So controlling for those. So out of this, we can construct 18 pseudo products. If you ignore, for instance, the price variation, and you look at the combinations over here, 9 times 2, so 18 pseudo products that we can construct over here. And if we look at all the options multiplied by the 3 prices over there, that the options that people are going to get is 54 different options that they can look at or they might get. So how did we do this? So we have participants which are given 8 choice sets. So each person makes 8 choices. And each choice that they get, they have to pick one of the 4 products that they've been given. So the 4 products are randomly drawn without replacement. So 4 random alternatives are drawn from a set of 54 without replacement to construct each choice set. Now, this type of variation is what's basically allowing us to identify the various parameters in our model. So it's done on prolific. The sample that we had was US beer drinkers, and they were all restricted to be between age 21 and 30. We wanted to see how college-going type of people would address this type of choice set. They were given a fee of £2 to participate. Collected 486 subjects in 3 days. Actually, it was more than that. Some of the people we had to throw out because they either did not fit in the age requirement that was there. Later on, when they were filling in the survey, their age requirement was wrong, or their responses were such that you could tell that they're really not paying attention, because we have certain ways of checking within the experiment that people are actually paying some attention to it, and there were certain choices that are clearly dominating the other ones, and to see whether they're making inconsistent choices or not. So, on some attribute, everything is better, and they're still picking the wrong one. So a few of those we had to throw away. So overall, 3,800 choice observations per product type. And of course, this can be scaled even more. There's a limitation, obviously, of this type of experiment, that you can do it for beers, but you can't do it if you were looking at airline mergers. Unless, you think through it very carefully who the subject is, who this. So this is the intra-brand one. So in the intra-brand, there's always going to be a brand name that will show up. This brand name that a person will get will be randomly selected, the brand. Now the 4 choices that they have, they don't have to think about different brands. So the 4 choices are all within the same brand. So basically, they have to pick out of these 4, and the scenario given is something to the extent that, Stella is coming up with a new product. These are the 4 that they're considering, variations. Which of these would you like the most? And they have to pick one of these 4. Okay, so what is it that we do? We observe these choices for all of the people, and then we say, okay, let's go to the model and think about the utility function. So we start with the standard utility function that might be there in a choice set. So person N chooses product J based on the price of product J, based on the product characteristics of product J that person N saw. So this doesn't really change by N typically. Well, it does actually, price changes. And these are the parameters, the alpha and the beta, that are listed over here that we want to estimate. Now, these parameters are for each person different values. We want to estimate those. We obviously cannot do that. So what we're going to do is that they have some sort of a distribution, which we assume is for price, log normally distributed, for other product characteristics, it's normally distributed, and we want to get a value of the mean and the variance of that distribution. Once we get that from the choices, then we can use this model or these model parameters in the other steps. So we want to know, for instance, for the price coefficient, which is alpha over here, what is the mean value from which it's drawn, and what is the standard deviation around it. So after doing all of this stuff, we take this data. Now here's the easy part about this thing. So variation, we've already controlling, so there's no issue of endogeneity of prices or other product characteristics. If you were to use aggregate market shares data, as is typically done in most empirical papers that are doing ex post analysis, it takes months and months and months of tweaking around and getting the estimates right till you get this. This stuff comes out in 5 minutes after the collection of the data, because once you've got this, you just load it up in Stata. You don't even have to understand a whole lot of stuff about what is simulated maximum likelihood estimator and things like that. You just put it in there, press the button, and I'll pop the results. So that's the beauty of this type of estimation, because once you have it at micro level analysis, there are canned routines that are available in standard statistical software packages that can be used to get those parameters that I was talking about. And so we did that over here. So we have the price coefficient, the coefficient for the volume, the level of alcohol that is there, whether it's a container, meaning can versus bottle, and the size of the can or bottle, which is small, medium, large, because we were using these three. So we get the mean value and the variation around it. So we get all of these. You can ignore the conditional parameter. That's just the average of the observed values over here. So the highlighted column over here is what we're getting. These are the mean parameter values that we estimated. There is another estimation that we've also done, which is that we take these parameters and product characteristics like price or ABV and interact it with the demographics of the participants to basically get, for instance, price coefficient or the mean value of the price coefficient by the demographic values. The demographics that we used were income, what is their income level, what is their age, and which state they are from. Turns out in our experiment, we did not have enough variation in these, so we were not able to get estimates that were substantially differing by demographic groups or by income. And the reason for that is because 75% of our sample was female, and the income where people were not reporting very accurately because they were mixing their stipends or not reporting those. And so we weren't getting much variation in the income aspect of things.
Just to clarify, what does it mean this negative coefficient for container?
So one is, I believe, so it's a dummy variable. One is, I believe, bottle, and 0 is can. So it means that they dislike the bottle. They have a higher preference on average for a can. And then there's a variance around that, and that's captured by this one. Jan, did I say it right, or was it the other way around? That's not that. Anyway, so if I remember correctly, it was basically this way. So those are the parameters that we get. Okay. So this part we've gotten. Now I'm going to move to the real world data and mixing these parameters with the real world data to essentially show how we can get elasticities. Now we're going to get the real world data for just one market, which is the national market. So Jan went and collected the actual average prices for a bunch of beers that are out there. Okay. He also collected the shares at the national level because they're available. But if you were doing it econometrically, this whole thing, you cannot do it just with one market. You have to then get it for each geographic market separately and many time periods and do all sorts of estimation. Now, when you want to compute the elasticities, for instance, here's a formula that we've written that comes out of these type of models for elasticities. This is a standard model, standard formula given in any logic type of estimation. But the key over here is to recognize that this thing, which is L hat, is the predicted probability of a person N, nth person choosing product J. This predicted probability is a function of product characteristics and the price. So what we can do is, given the product characteristics of the actual observed products, since we've already estimated the parameters, we can multiply, now that we've estimated alpha n and beta n, we can multiply the actual observed prices in the world and the actual product characteristics in the world to get the utility that a person is getting. Then we say the person is going to choose that product for which they have the highest utility out of these things. And from that, we can then get the probability that an nth individual is going to get the jth product. Okay. So we are fitting in the real observed values of these prices and product characteristics to get the utility. Okay. This Sj is the predicted share, which is also an aggregate from the probability to the share. And then we multiply it with the actual observed prices again, not the values that we had fed in. We would feed in the actual observed prices and essentially get the own and cross price elasticities for all the products. So So Jan went and got for 18 or 20 products, the top selling products of beer. He got the product characteristics, he multiplied, got the prices, fitted it in here, and that's how we got our elasticity estimates. Okay. So to show you what they look like, here's a bunch of products that are listed here. So Bud Light is on top, Budweiser is the next one, and so on. And we have on the leading diagonal all the estimated price elasticities of these products. And on the off diagonals, we have the cross price elasticity between any two sets of products over there. And the color coding over here is matching the ownership. That, for instance, the first 7 are by AB in how it's pronounced, manufacturer. The second one is by Coors Group, Miller Coors Group, and then that's up to 13 and so on. And so what we can see over here is that these products are fairly elastic. The demand is very elastic for these, as estimated by us in this experiment using the national level single prices and product characteristics. And the cross elasticities are also quite reasonably placed over here. By reasonably, I mean compared to some of the estimates we've seen in academic literature. Okay. So how reasonable are they? Well, here's a recent paper, Miller and Weinberg. This paper estimated the own and cross price elasticities for several products. And they report in their paper what the own price elasticities are. They don't report the cross price elasticities. So we compared our estimates with theirs. Now, there's a bit of a difference.
Actual sales.
Sorry, what?
These ones are actually, the right-hand ones are based on actual sales.
Actual sales data, yeah. So this is based on actual one. It doesn't match the period completely. I think this is a 2017 paper, but the data is probably 2000. Sorry, what?
This is the crucial test for your.
Yeah, this is our kind of our external validity, so to speak, test. That here's ours. Here's what they got for similar products, but they did it with, I think, 2012 or 13 data set maybe, because the paper was published in 2017, but the data is slightly older. It was for the American market and based on actual retail standard level data. And these are our estimates. So I think that, I mean, they kind of look reasonable, what we are doing. They're not completely crazy estimates that we're picking up like -20 or -1 or whatever. They're coming out fairly similar.
Sorry, I'm not sure sorry, if you permuted randomly their numbers, you could say the same, you know. You randomly permutate
Yeah, you could, but my point is that, yes, you could permutate them. So I'm not matching them line by line. I'm saying that what you're seeing over here is that the range of own elasticities for most products is coming out around -4, -5, as opposed to ours, which could have been -10, -12, or -1, or in the inelastic region, -0.1, -0.2. So we're not saying that they are matching by a permutation method, but they're in the same ballpark, is how I would put it in. And that's the closest we can check, you know, because we don't have real data for this. Then I said, okay, we've got the median elasticities by our paper, our Weinberg's paper. Then what we did was the second part, which is we said, okay, let's back out marginal cost. Marginal cost, remember, there's nothing in the data that we estimate that tells us marginal cost. We've not estimated those parameters. We've now taken the parameters and backed out through Nash-Bertrand pricing model. We say, what is the marginal cost? The way you want to think about it is that price minus cost divided by price for a monopolist is usually equal to 1 over elasticity, if there was a single product. That same concept applies to oligopoly models as well, where price minus cost divided by price is not equal to 1 over elasticity, but a function of the full elasticity matrix that I had presented, the 19 by 19. So using that, then you can say, okay, we have the elasticity matrix, we have the price that we can observe. Let's manipulate this equation. It's got one unknown cost and figure out what the cost is. So that's how you get the marginal cost in that. And so we get the marginal cost in ours, based on the real data, to be $9.17. Okay? per pack that we're showing. And from that, then we say, let's figure out the price cost margin that these guys have. We get an estimate of about 22% in our data set, price cost margin. Miller and Weinberg had reported from their data, the price cost margin, which they report was 34%. So we are a little underestimating it, the margin over here, how we did it. But remember, these are two different data sets, different periods. We're not exactly using their prices or what they observed. We collected for 2019 the real observed prices, which could have changed by then. Then we simulated a merger. And basically we said, okay, if AB InBev merged with Miller-Coors, what would be the predicted changes in these? Because if you're showing as proof of concept that you can do all of this ex ante with just a simple computer and quickly collect this information, we should be able to show this. So we created a new firm with this merger where all the way up to firm number Coors, BNQT, these products merge and become a new product or a new firm. And then we predict what the new prices would look like, what the new price cost margins would look like. So these are the old price cost margins. This jumps from 28% to this 30.6%. We look at the percentage change in market shares and what is the percentage change in prices that we predict out of this. So 4-ish% change in prices that we get out of this. Yeah, 5 minutes left.
Nothing gets cheaper.
Sorry, what?
But nothing gets cheaper for the consumer.
No.
Clearly.
Of course not. Well, I mean, so sorry. I should be careful in this. So the way discrete choice demand models work, there's a functionality built in there that by design, when you do these simulations, prices can never go down in a merger simulation. They can either stay the same or go up. And that's essentially a function of these cross price elasticities. These cross price elasticities are restricted to be positive always, or zero at most. If they could have been negative somehow, which might happen when the products were not substitute formulas, but sometimes complements, then you can get effects in there where some prices go up and some can potentially come down, particularly when there is a multi-product framework that each firm has multiple things. Then you can get those type of effects. But in these type of typical estimations, in these simulations, almost by design, you will see them to either go up or stay the same in the discrete choice model. So after doing that, we did quickly treatment 2, and I just want to make a few points about this. So in treatment 2, what we have is we added the brand logos up there to see how people focus on these choices, and repeated the whole experiment again. This column is showing you the parameters that you've already seen in the previous slide. This, by comparison, is showing you when we've given them this type of a choice. And then these are two different methods of doing the econometric estimation, whether you allow for brand dummies or not in the econometric equation. They don't seem to matter too much. You get very similar estimates from that, but they're very different from this. So the end result of this will become that the demand, because these parameters are much smaller, demand becomes very, very inelastic. And this is the point I want to draw in comparison to the Guns paper that I was talking about, where they're also showing you pictures. If you look at their conclusions, they find they didn't do with or without the brands and so on. They find that the demand is extremely inelastic for guns. Now, that may be the case in the US anyway. Everybody likes their guns. You cannot take away a person's guns. But the low level of elasticity that they're getting in our model comes, at least from our experiment, seems to be coming from showing that picture, the branding effect going in there. So there may be something over there to explore further, that how strong is this type of an effect in a lab.
But which way, I mean, you were saying before your unbranded one, it looks like you're getting the same magnitudes as the real market.
Yeah, so the unbranded one is getting similar magnitudes as the real world data.
So the putting the branding in your which way is it? Is that's moving it away, is it?
Yes, that's moving away. So that's this picture. So here's our result. Here's Houseman et al.'s result on elasticities for beer market. Here's Miller and Weinberg. Here's our result first set. Here's in Slate, here's Rojas and Peterson, their elasticity estimates. Here is our result without with the brand dummies or without the brand dummies, but the two where we're showing them the actual logo. That goes way to the other side. So we get in the inelastic region of these things. So our experiment seems to say that, look, if you believe some of these external other papers' estimates and which of our estimates come closer to that, that's the one where we're doing more intra-brand.
It's not a surprise then, because you
It is a surprise. I was expecting it to be the other way around.
They're going to the supermarket, they're very conscious of the brands, aren't they? So it seems like something very peculiar, right?
So our explanation is the following. Yes, I think capturing brand effects is very important. But if you're going to do it in a lab, in a what do you call it? Yes, not incentivized, then people can engage in just listing their favorite brand and picking that, regardless of the product characteristics. So if you want to have them focus on the product characteristics, then make sure that they're not thinking of different brands at the same time. Because you're trying to get these parameters as accurately as possible. And if you were interested in studying the brand effects per se, then this is not the experiment to do. Because what this is showing is that attention really is focused better if you're not thinking of different brands.
I suppose that is right. If you think of you can focus on the brand, you focus on the price, and if you're in the supermarket, you have to spend the money. You focus, the price sort of looms up more than it does when it's hypothetical. So I think I agree, that's right.
Yeah.
But you wouldn't know what the right mix was, other than
Not initially, we didn't know. In fact, I was expecting the second set to give us more accurate results, because I thought that people should be able to focus on the brand, because in the real world they are being bombarded with advertisements and they should be able to capture that. So the result came out exactly opposite of what we thought was the right treatment. So that was sort of a learning message out of this, that perhaps doing it within a brand. I mean, it's cheap to do both each time, because it doesn't take you that much extra effort to do both type of experiments. And that's it. That's the summary I have over here. How am I doing on time, Joe?
Good, yeah. By the end of the
Okay. So more detailed questions. Yeah.
So I'm just considering about that unbranded experiment in online, because now, if I'm correct, so in that utility function, so we are not considering about their history. I mean, so since we are going for real consumers, but so for the moment, so we don't consider their history. So maybe if in case as you show they are a brand, maybe that's not the brand that they wish to have. In that case, maybe they just go through the characteristics. Or for another consumer, maybe they are getting a brand just because you are showing a brand, and maybe that brand is the brand that they usually consume. So maybe that creates some effect.
Yes, that is what we're thinking, that because these are not incentivized experiment, when we're showing them the brand that they are looking at, choice A versus choice B. So in this type of an experiment, we think that they're not paying attention to any of this stuff.
Mm-hmm.
They're just looking at the picture and then saying, oh, I like XXX because I like their ad, and that's a macho guy picking here. I'm just going to click on that. So that's why you're picking the elasticity of demand to be so low that they're showing inelastic. Yeah.
In marketing literature, it's called the Pepsi problem.
The what problem?
Pepsi problem.
Okay.
Have you heard of it? So, and it's about the power of branding and the branding effects, and there's different kinds of branding effects, and it describes a situation where in blind taste tests people prefer Pepsi, but they always say their favorite is Coke if they're asked what they drink and what their favorite is, and it describes the branding problem where the branding counteracts actual preferences on characteristics. So what you're seeing is the Pepsi problem at work in your experiment here, and it is probably exactly what you just said, where they're not seeing the.
Yeah, I mean, this choice is so salient that they're not
Yeah.
looking at this thing anymore, and that's why we think that even though design one looked more flawed, in picking out the parameters of the utility function, it seems to be doing a better job.
It probably will. I mean, it probably will in almost any situation where you have long histories of brands.
I mean, so our initial thought was that we should allow for these brand effects to kick in because people are motivated by that and we're capturing a better real world thing. I think that would have worked had there been an actual choice where they had to put their money where their choice was. Then they would have to click on it and say, how much am I losing by buying this particular beer, which they do in the real
But
world.
even then, the branding effects probably still mess things up in terms of representing their actual preferences on the characteristics that you're interested in.
Well, that I wouldn't count as messing up. If we had incentivized, because in the real world they are, the choices are based on what advertising they're seeing. It's just that if advertising parameter was very important to us, which we've not put in here in this model at all. But imagine one of the characteristics of the product was how much advertising is going on, or if it was, as is often done in these, that where is the location of the product in the store? Is it front of the aisle or is it back, somewhere in the back of the store? Is it on promotion or not? Those type of things. They can affect the choice, they can affect the demand. If those were very important in your merger simulation or something like that, then you would not be able to capture that value.
We have a question from Jens Profil.
Yeah, go ahead.
Yeah, hi Farasat. Thanks. I think it's a very nice paper. But I would like to relate a little bit to what I guess Sally just said. So if the brand effect is so strong, how relevant is all of the BLP structural kind of exercise in the first place? Kind of is it that academics kind of have kept themselves kind of busy for the past 2 decades or so with doing something very sophisticated that few outsiders understand, but in the end, the major effect is just trumping everything else, and the details of the sophistication are not really important.
No, not at all. I don't think that's the case. I don't think BLP has been wasting time or people have been wasting time. Though they are working with the real world data. So the brand effect is already cooked into the choice that they've made. So the shares that you see are already over there. Now, it could be that in some of the estimation where advertising has not been particularly accounted for in the regressions, that, okay, that's an omitted variable. But is that creating an omitted variable bias? I don't know. It is in the sense that if you have advertising going on, you've not accounted for it in the real world regressions, regressions with the real world data, then that branding effect is sitting somewhere in the error term. And then you can say that error term is correlated with the price, but that's why we go around crazy, spending months and months trying to find instruments that give us the right variation to construct instruments for the prices, because those are precisely the type of things that we're worried about in the real world data, that there are lots of things that are omitted from the utility function specification, and hence the demand function specification, that are making a simple OLS type of regression invalid. So I would not say that those are wrong. I'm just saying that in our context, in the lab, we cannot capture the branding effect that easily.
No, I understand that you did not say that. So I want to be kind of to go a step ahead and be a little more provocative, like saying, is it what, I mean, not what you, but kind of what this literature has done without the experiments, but kind of focusing just on the data from real markets. And so is it that they have kind of studied 20 different variables that might have an impact, but in the end, it's the brand thing, at least among these major consumer brands and consumer products?
I don't know the answer to that. I mean, I've certainly seen some papers where some sort of marketing effect or placement in the market is over there. So for instance, even in Aviv Nevel's work, you'll find that when he's doing ready-to-eat cereal type of estimation, one of the parameters is location in some of these papers in the store. So is it front of the aisle or not, or whether or not this product was on promotion or not. So they do capture these things in some papers. In others, they don't. I don't know how many papers fully focus on the marketing effects or in general promotions.
It seems to me as though, looking at this, though, in a way, you must have been, in a sense, your unbranded one. It must be an element of luck, really, that you've got this good match, because what you're saying is basically saying, well, you can present the data, This is standard in all these sort of contingent valuation studies. Different ways of presenting the data give very, very different results. This is obviously consistent with that. You've got a number of dimensions, and if you put something in your display that brings up the brand dimension, you drastically changing the results. So probably if you put something on any one of the attributes, if you kind of direct people's attention to it, it sort of feels as though, although it is remarkable that you get this good match, but it seems to me implausible that with just giving people numbers when they don't, I mean, numbers aren't what they would work with in life. They wouldn't be actually processing numbers, and the supermarket would be kind of activating all sorts of psychological effects. The fact that you happen to match the real world data by a very sort of abstract mathematical looking display, and then when you add in one bit of framing, you get something completely different. My hunch would be that you've been lucky, really.
Your hunch would be?
That you've been lucky in the sense that it wouldn't be a general. My hunch, it wouldn't be a robust result that by just removing the branding, it always match the real data. It seems as though just, if it's so sensitive to one small bit of labeling, then the fact that one particular labeling matches the real world suggests it's luck. And given what we know about contingent valuation anyway, this is what this is. Isn't it?
Yeah, that would be an interesting thing to see whether this type of choice shown up there or not moves other data sets this much or not. That I don't know. I cannot expand to the generalizability.
That would be an actual test, wouldn't it? Really, to see whether if you did a different market and you use the same sort of display, can you again match the actual data?
Yeah, that whether one learns something from choice set 1 versus 2.
Mm-hmm. So,
in this case, we didn't know ex ante which one is going.
No, obviously we don't know this.
I had talked to Aviv Nevo, who's one of the academics who's done a lot of work on this long time ago. In fact, pushed the BLB method much further out, and his recommendation was to try and put these brand effects in there because he thought that those are going to be very important, and so we did put in the second treatment.
I think we'll have to pause there in case anyone needs to shoot off and just say thanks, Farasat.
Thank you very much.
Anyone who wants to stay longer is welcome to.
Can I